Today we shall discuss some important organic questions which has come in several years uh, in different competitive exams like NEET, like JEE mains. Number one, first, all these are organic questions. So these have come in several years. Repeatedly I am saying. First question is paratoluidine. This compound, when treated with acetic anhydride, produces A, and this A, when treated with bromine in presence of acetic acid, produces B. A and B are, we have to identify A and B, and we know that this compound, that means paratoluidine, when treated with acetic anhydride, NH2 reacts with acetic anhydride group. Acetic anhydride is CH3, C double bond O, CO, CH3. This compound is acetic anhydride. NH2 group, due to the presence of lone pair, acts as a good nucleophile. It attacks this center, nucleophilic center, carbonyl group, and liberates this part. So, by dissociating one H plus ion from NH2, it produces the final product NHCOCH3. Para position occupies CH3 group plus CH3COOH. So this will be the A. Now in between two groups, this is paramethyl acetanilide. NHCOCH3 group is the acetanilide group. Now NHCOCH3, due to the presence of lone pair over it, it is more ring activating as compared to CH3. Though we know that both NHCOCH3 and CH3 both activate the benzene ring, but NHCOCH3 has greater activation substance than that of CH3. So if or whenever this compound, when treated with Br2 in presence of acetic acid, this compound NHCOCH3 when treated with bromine in presence of acetic acid, it produces, because this is the governing group, so it controls the orientation of the incoming Br nucleoelectrophile into the benzene ring. So with respect to this is ortho-para directing towards an electrophile. So with respect to this, either ortho or para position will be occupied by the Br. Already para position is occupied by the CH3 group, so it must come at the ortho position. So this will be NHCOCH3. With respect to ortho, NHCOCH3, ortho position is this, and here the CH3 group is here, and this is called the second compound B. So thus we can identify which one is A and which one is B here. Second question is the stability order. You have to write down the stability order of these three compounds. All of these are oxides. All of these contains NO2 group with this. Now we have to compare the stability between these three. Now the first compound, number 1, this has no resonating structure because this is the structure of first compound. But number 2, it has a resonating structure with this species because it resonates, and hence it is somewhat more stable than that of the first structure. But NO2 group doesn't come into the resonance with this oxide anion. But in case of 3, if we consider the structure of 3, this is the structure in double bond O, single bond, double bond, single bond O minus. So this negative charge enjoys the resonance stability with this NO2 group also, and that's why it shows the maximum stability, because the NO2 group comes in the resonance with the oxide anion, where this part in this compound, in this anion actually, number 2, only O minus is in resonance with the double bond CH2 group. But here no such type of resonating structure occurs. That's why the order of the stability is 3 greater than 2 greater than 1. Number 3, this is the structure. This is treated with HBr in presence of heat to produce A. Now A, when treated with sodium and diethyl, produces B. So you have to identify A and B first. Now the first compound A, how it comes? This is the structure of the initial compound which is given in our question. CH2Br, but this is an ether. So when it is treated with HBr, the oxygen atom is gets protonated to form positive charge, and hence the Br minus here, the Br minus attacks to this center and dissociate this linkage to form this compound OH Br CH2 Br. Here this is the compound first it forms. Now this when treated with sodium in diether, so this is A. This when treated with sodium diether, an intramolecular Wurtz reaction takes place. Intramolecular Wurtz reaction takes place. OH, these two actually Br removes due to the presence of sodium, and hence these two join to form such type of group. This 1, 2, 3 and 4 carbon. 1, 2, 3 and 4 carbon. This is the structure of the final product. This is B, A and B. These two are the compounds A and B. These three are the compounds. One is the triethylamine, second is the ammonia, and third is the diethylamine. Correct decreasing order of Ka value. We know that. How we can consider the Ka value? An acid when dissociates it forms H plus and A minus. So Ka can be calculated as concentration of H plus A minus divided by concentration of Ha. This is the expression of Ka. Then Ka is the dissociation constant of the acid. Higher the value of Ka, higher will be the acid strength. But all these are the bases, because all of these contain lone pair over the nitrogen atom. All of these contain lone pair over the nitrogen atom, so they act as Lewis base. So higher the Ka value, higher is the acid strength. So higher decreasing order of Ka, that means first will be the highest acidic, that means least basic. Decreasing order, first highest acidic, that means the least basic. So least basic to more basic, we have to arrange this. Now first, which one is the least basic? This is the triethylamine. We know that plus I effect of the alkyl group of R group increases the basic strength, plus I effect, basic strength. But ammonia has no such type of plus I effect. That's why it is the least basic substance among all. So 2 is the first part, least basic substance, 2. Now the second part among these two, triethylamine and diethylamine, we know that plus I effect, here the triethylamine shows maximum plus I effect, but due to the presence of 3 bulky sized ethyl group, the lone pair is trapped, and hence the lone pair bonding ability gets dropped. So its Lewis basic property is somewhat less than that of this. So that's why diethylamine is the most basic among these three. So the order is 2, less than 1, less than 3. So this is the order of the basic property. Least basic is 2 and the most basic is 3. Number 5, this part is the phthalic anhydride. Phthalic anhydride is treated with chlorobenzene in presence of anhydrous LCl3 to form X. X on hydrolysis in presence of water produces Y. Now we have to identify which one is X and which one is Y, the structure of X and Y. Now the first, oxygen, anhydrous LCl3 in presence of this, it activates the chlorine, actually activates the benzene ring through its para position. It attacks this center. Actually chlorine, how it activates? Double bond dissociates to form resonance stability. This part goes here. So the first structure will be like this, double bond Cl plus it forms double bond here actually, and it forms a negative charge actually, and others to double bond, and hence this will be the actually nucleophile which attack this center, nucleophilic center, and bond dissociates. So the structure will be phthalic anhydride when treated with chlorobenzene in presence of anhydrous LCl3 O minus, and this will be the C double bond O reacts with the through the para position of the benzene ring, through the para position of the chlorobenzene actually, and ultimately by losing one hydrogen atom from the para position it becomes aromatic, so O minus, and anhydrous LCl3 acts as a Lewis acid, so it forms AlCl3, that means it coordinates with this, so actually LCl3 will be minus and oxygen forms a bond with this. This is the X here. And when it is treated with water, it forms, when it is treated with the water molecule, it forms actually OH. When it is treated with water, it forms C double bond O OH and releases this LCl3, and here C double bond O parachlorobenzene is the substituent here. This is the Y. So here this is the X and this is the Y. Already I find it.